गुड मॉर्निंग स्टूडेंट्स, सहायक एजुकेशन में आपका स्वागत है। वेलकम टू सहायक एजुकेशन 10th क्लास के सीरीज ऑफ मैथ्स वीडियोस के अंदर टुडे वील बी टॉकिंग अबाउट triangles. Basically it is similar triangles and we'll be covering each and every concept of the similar triangles or triangles. Request you to please watch the video from beginning to end in case you want to get more than 90% of the marks, and please subscribe to our channel because before the exams we'll be discussing about a few questions which might come in exam and which will be very helpful for your marks. Okay, let me just share my screen without wasting any time and start triangles. I hope you can see my screen. So triangles. So before understanding the triangles and getting into certain things, I want to talk about what is congruency means. Okay, which will be very helpful in this entire chapter. What is the meaning of congruency? Okay, the congruency means exactly same. That's called congruent. Okay, we'll be discussing about triangles a little later, but before that, it is actually important to understand what is the meaning of congruency or congruent. In case I say two things are congruent, what does it mean? That means they are exactly same. So let's take an example here. So this is one triangle and this is another triangle. Now these two triangles names are different, like ABC and EFG, but these two triangles are exactly same. This side is equal to this side. Another side is equal to another side, and the third side is equal to third side. And all three angles are also equal. So one angle is equal to 1, two angle is equal to 2, and third angle is equal to third angle. Exactly same figure. They can be tilted or they can be moved here and there, but they are exactly same figure. If I put one figure on the top of another one, it will exactly it will take up the entire space. Okay, and we consider that basically we write it in this format. This is the like when we say say 2 is equal to 2. Okay, so it is equal to sign, and this is the congruency sign. So we put equal, and for basically for figures we'll write like this. So it is congruency sign. So when we say triangle ABC is exactly same with triangle EFG, or triangle ABC is congruent to triangle EFG. Now, we'll take the circle. Okay, when we're talking about circles, two circles will be exactly same in case the radius is same. In case the radius of two circles is same, that means they'll be exactly same. So these two circles will be congruent circles. Similarly, if I take one square with a side 5 centimeter, that will be congruent to another square with side 5 centimeter. So see, you can see that they are the second square, it is tilted in one direction. This one is tilted, but this one and this one are exactly same. So in case I put one square over the other, it will overlap exactly the same space. Okay, it will take up exactly the same space. So these are congruent squares. Now coming to, say, there is one angle 45. Now this is also angle 45, but maybe the direction is different, but angles are exactly same. These angles are exactly same. If I tilt it and move it, I can exactly put it on the other angle. These are called congruent, and congruents are denoted by, as I mentioned, equal to sign, and we put something on top of it. So this is congruency. Okay, coming to next. What are similar articles? Now we'll come to similar articles. What is the meaning of similar? Now, if I take an example, now you can see this small dog and the big dog. Okay, these two dogs are exactly, or they're not exactly same. Why? Because this is small, and this is big. This is small and this is big. Okay, but they are similar. Similar means that if I say the size of this ear is proportional to size of this ear. So if say the size of this ear is 1, the size of this ear is 2. The size of, say, his eyes is 1x, then the size of his eye is 2x. So it is in proportion. Everything is in proportion and the proportion is same. So say his tail is in the same proportion as the tail of this one. So his tails are in the proportion as his legs. So I can see this dog is exactly similar, not congruent, but exactly similar to the other dog. Now same goes with these butterflies. Okay, could be a possibility that this wing is X size and this wing is 3X size. Now if I say the body of is say Y and this body is 3Y. Okay, so these are exactly, or you can say similar articles, similar pictures. Now you can see we have seen Taj Mahal. Now this Taj Mahal also, you can see a big picture, small picture. Both the pictures are similar. Okay, they could be vary in size. They are not exactly same. They're not congruent, but they are called similar. Now, if I take this example of two triangles, now these two triangles we can see, not two triangles, sorry, this is two polygons, quadrilaterals. You can see all four angles are equal. So this angle 45 is equal to this angle, this 90 angle is equal to 90 angle, and other angles are also exactly the same. Okay, and the sides, the angles are exactly the same, but if you look at the sides are in a proportion. Sides are in a proportion. So what kind of proportion it is? So say this side is 11, this side is 11, and this side is 10 times of it. This side is 8. Now this side is 10 times of it. This side is 4, and this side is 10 times of it. This side is 15. This side is 10 times of it. Now you can see the proportion is same. The proportion in which the sides are drawn is exactly the same. Okay, and the angles are angles are exactly the same and sides are in proportion. Angles are exactly the same and sides are in proportion. I'll repeat it one more time. Angles are exactly the same and sides are in proportion. Okay. Now coming to next. What is the difference between similar and congruent? Now, when we talk about similar things, we say this is the symbol which we use. So if I say triangle ABC is similar to triangle DEF. But if I have to say congruent, if the two triangles are congruent, if I'll say triangle ABC is congruent to triangle DEF. Okay. Now, similar is proportionate. So if I look at this one and the size of this one, the size is proportionate, though the angles will remain same. This angle will be same, exactly same. The angles are congruent, but the size of the figure is proportional. So if this side is, say, X, this side is 2X. Now, same goes for this figure, same goes for this figure. But in congruent of the triangles, the sides has to be exactly same. So the angles are same, these angles are same, and these sides are also exactly the same. So this side is equal to this side, other side is equal to other side. So the sides are exactly the same. So we're talking about the similar triangles. In similar triangles, what are similar triangles here? Now, two triangles are similar if their corresponding angles are equal. If the corresponding angles are equal, so this says corresponding angles are equal, and the corresponding sides are in the same ratio, and the corresponding side in the same ratio. Now you can see this figure. Now, angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. And the sides are in proportion. You can tell I'm not written the size of the sides. The sides are in proportion. So we can say the triangle ABC is similar. You can see this is the symbol of similar which is used here. So these two triangles are similar to each other. Okay, so we can, in such cases, AB, the sides AB by PQ is equal to AC by PR is equal to BC by QR. So sides are in proportion. So then only it is similar. Then only it is similar. Okay, one more thing which is extremely important is I can, here in this case I have written triangle ABC is similar to PQR. I cannot write that triangle ABC is similar to RQP. I cannot write this. This is wrong. This is wrong. RQP is the same triangle. RQP is the same triangle, but I still cannot write it. Reason being, the angle A is not similar to is not equal to angle R. Angle B is not equal to angle Q. Angle C is not equal to angle P. Okay, so we have to write in the same order. We have to write in the same order in which they are proportional. Please remember this part. I'll explain it one more time. So this side, when we say this is angle 1, this is angle 2, and this is angle 3. Okay, this is here, it is angle 1, angle 2, and angle 3. When I'm writing two triangles as similar, I have to write the sides between 1 and 2, and here also for 1 and 2. So I have to write AB and divided by PQ. So this is between angle 1 and 2. Between angle 1 and 2. Now, between angle, if I am writing 2 to 3, then in both these triangles, it should be same. 2 to 3 is BC by QR. And 3, 1. So 3, 1 is CA by RP. So we have to write in this format. You have to write in this format. Please remember this part. People make a lot of mistakes when they don't write it in the same format, and they lose a few marks here and there. Okay, they make some mistakes in finding the exact value of the side and things. So please remember this part. When we're writing about two similar triangles, when the sides are in proportion, at that time we have to write the proportionate sides together. So, what are the proportion sides? How will you find out? You have to find from the angles, because the angles are exactly same. So you can name the angles as 1, 2, 3 and take the angles, say 1 and 2. So between 1 and 2 side is AB. So I'm writing AB here. Then in the other triangle between 1 and 2 is side PQ. So I'm writing PQ. So ratio should be written in this format. Okay, this is to avoid any kind of errors. Okay, now look at this triangle, two triangles. Now these two triangles, you can see the angles are exactly same. Angles are exactly same. One angle is equal to one angle. Two angle is equal to two angle. Third angle is equal to third angle. And the sides you can see are in proportion. This is 8. This is 16. 2 times. This is 9. And this is 18. 2 times. This is 14.1. And this is 28.2. 2 times. The sides are in same proportion. Okay, so these are two similar triangles. Okay, so coming to a theorem. This theorem is pretty important, very important in this chapter. And in your board exams, one theorem will come. So you have to prove it. It's a 4 to 5 mark question, or between 3 to 5 mark question, a theorem which you have to prove. And you have to write the theorem steps in the exactly same order. There will be hardly 15 to 20 theorems in the entire 10th grade. So if you, out of those 20, if you go through all those 20, you know one question is going to come from those theorems. Okay, let's come to this theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Okay, so before doing this theorem, okay, I want to understand. I want to tell you one concept. Okay, so that you understand this theorem better. So I'm making two parallel lines. These are two parallel lines. Okay, and I am just taking some side as AB, or maybe cutting it into a line segment. Line segment is a part of the line. I'm just cutting it AB, and this AB, I'm making a triangle like this. So what is the area of this triangle? The area of, I'll say the distance between these two lines is H, because the distance between two parallel lines will remain exactly the same. So what will be the area of triangle ABC? So area triangle ABC is equal to half into base. Base is AB multiplied by H. Okay, you know this area of a triangle is half base into height, and we know the height here is also h. Now, if I make a triangle like this, now I'll say this point. What is the area of triangle ADH? Area triangle ADH. That will be equal to, again, half into base AB into height. Again, the height is from here. So basically, when I'm making basically, even if I extend this line here as a parallel line, see, this is not drawn exactly parallel, but consider it, these are parallel lines. Now, if I make another line like any triangle like this with base AB, and this point is, say, Q. So what is area of triangle AQB? Area triangle AQB. That will again be half into base AB into height, because height again is the same. So what I meant to say is, if we have two parallel lines and this is the base, so area of this triangle is equal to area of this triangle is equal to area of a triangle made in this format. So the area of any triangle with the same base and between the same parallel lines remains the same. So area of a triangle with the same base, area of a triangle with the same base and between the same parallel lines remains the same. So I'll make like this. So area of all these triangles which I've made with the same base A and B will remain same. Okay. Now with this, we'll prove the theorem. I'll just clear it up and then I'll come to the figure. So what we have to prove here is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Now, if I just write the nomenclature, this is A, B, C, D, and E. Okay, so we have to prove that, and we know that D is parallel to BC. And what we have to prove is that AD divided by DB is equal to AE divided by EC. So the line D is dividing AB and AC in the ratio AD by DB is equal to AE by EC. Okay. This is what we have to prove. Now, to prove that, there are certain things, some certain constructions we have to do. So I'm joining the line BE and I'm joining the line DC. Also, I'm making a perpendicular from point D to AC. So this is the perpendicular. This is a 90-degree angle. And from point E, I'm making a perpendicular to AD. This is 90-degree angle. Okay. So what is the area of triangle ADE? I'll write it at area triangle ADE is equal to, okay, if I consider AD as base, of the triangle, then the area of triangle is half into AD into, I'll just write it as P and Q, into EP. EP is the perpendicular to AD. And area of triangle is ADE is also equal to, if I consider a different base, I'm considering AE as base. If I consider AE as base, the area of triangle ADE is equal to half into AE multiplied by, what is the perpendicular to it? DQ. Okay, so this is one and this is the second one, and both the areas are equal. Now coming to what is the area of triangle BDE? We are taking area of triangle BDE. Area triangle BDE is equal to half into base, considering base as BD. So I'll just write as BD multiplied. Now, what is the height? EP. Height is EP. So if I divide both the areas, so area triangle ADE divided by area triangle BDE. This comes out to be half into AD into EP divided by half into, instead of BD, I'm writing DB, line segment, into EP. So, and finally it comes out to be, because half will cancel out and EP will cancel out, it comes as AD by DB. Okay, why we are finding AD by DB? Because here we have to prove that AD by DB is equal to AE by EC on this. So we want to come to that level. Now, what is area of triangle DEC? Area triangle DEC. Why we are taking it? Because we want EC. Okay, we have to, here we have EC, so we have to get EC. That's why we're taking area of triangle DEC. What is it? It is half into, considering EC as base, so EC multiplied by, what is the height? TQ. TQ is the height. Now, similarly, as we have divided here, what we are doing? We are doing area triangle ADE divided by area triangle DEC. It comes out to be half into, so instead of taking the previous area, this time we are considering the area as mentioned here. This is also the area of triangle ADE. So I'll say half into AE into DQ divided by area of triangle DEC. What is it? Half into EC into DQ. Now it will also cancel out. It will also cancel out half, and DQ will cancel out. So it will become AE by EC. Okay. But we know that area of triangle BDE, okay, area of triangle BDE, this area is equal to area of triangle DEC. DEC. Why is it same? Because these lie between the same parallel lines, as we discussed just now. Okay, just proved earlier that two triangles between the same parallel lines and on the same base will have the same area. So area of triangle BDE is equal to area of triangle DEC. So area of triangle BDE and area of triangle DEC is same. So I can say that AD by DB is equal to AE by EC. And that proves that the line DE is dividing AB and AC in a ratio, that is AD by DB is equal to AE by EC, in the same proportion, in the same ratio. Okay. Please go through this. Okay, you can go through it 1 or 2 times to understand it better. Now coming to the another one, which is the converse of this theorem. So previously we have proved that in a triangle, if there is a line parallel to the third side of the triangle, or one side of a triangle, that line divides the sides, the other two sides, in the same ratio. Now here what we have to prove is, a line divides any two sides of a triangle in the same ratio, then the line is parallel to the third side. So it is purely converse of what we had just proved. Now to prove it, just write the nomenclature of it. Let's write A, B, C, and D and E. Okay, what they have given? They have given that it is dividing in the same ratio. So they've already given. So AD by DB is equal to AE by EC is given. It is already given to us. It's given. Okay, what we have to prove? To prove is that line DE is parallel to BC. Line DE is parallel to line BC. This is what we have to prove. Okay, to prove that. So we are considering that DE is not parallel as of now. Okay, they have already given. We don't know whether it's parallel or not. So what we are going to do, let's create a line. Let's create a line which is parallel to BC. So this is the line. So this is the line. Okay, we'll point it as E dash. Okay, so D, we have construction. Okay, this is constructed that D E dash is parallel to BC. So we have constructed this line. So when we construct this line, we know from the previous theorem that AD divided by DB is equal to AE dash divided by E dash C. Okay, but we already know, it's already given that AD by DB is equal to AE by EC. So this, if I say this is first and this is second, then we can say that AE by EC is equal to AE dash divided by E dash C. What does it mean? That means E and E dash is the same point. Is the same point, or line DE is same as line DE dash, or we can say that DE is parallel to BC. DE is parallel to BC. Okay, it was a pretty simple one rather than the previous one. It is pretty simple one. Now coming to the next question. Coming to the next. Oh, it's also a theorem. So in a given triangle, corresponding angles are equal, then their corresponding sides are in the same ratio or proportional, and hence the two triangles are similar. Okay, so what they want to communicate here is there are two triangles, and in these two triangles, if the angles, the three angles, so if I say this angle is equal to this angle, the second angle is equal to second angle, and the third angle is equal to third angle, then these two triangles are similar. That means their sides are in proportion. So if I just put some nomenclature here, ABC, DEF. So DEF. So we have to prove that AB by DE is equal to AC by DF is equal to BC by EF. This is what we have to prove. This is we have to prove. Okay. What they have given, that the angles are exactly same. See, when the angles are exactly same, what we are doing is, say, we have to construct a few things here. So what we're going to construct, we'll construct M point here and N point here, so that DM is equal to AB and DN is equal to AC. Okay, so we are creating a triangle here, DMN. So triangle DMN is congruent to triangle ABC. So we have constructed a triangle which is congruent to ABC on top of DMN. Now we know that if I consider this angle is angle M, okay, and this angle is angle N. So I can say that, I'll just write it as 2 like this and like this. Okay. So we can say that angle B is equal to angle E. Why they are equal? They are equal because it's given. Okay. This is given that three angles are already equal. Okay. Angle, this what is given, I'll just write it. Angle A is equal to angle D. Angle B is equal to angle E. Angle C is equal to angle F. This is given. Okay, because this is given, so we can say angle B is equal to angle E. And we know that angle E, not angle E, angle M, we know angle M is equal to angle B. Why? Because triangles are congruent, because of CPCTC. You can say CPCTC, congruent parts of congruent triangle, CPCTC. Okay, so congruent part of congruent triangles are congruent, so CPCTC. Okay, so angle M is equal to M, and what does it implies? That angle B is equal to angle E. When angle B is equal to angle E and angle B is also equal to angle M, that means angle B is equal to angle E is equal to angle M. Angle B is equal to angle E is equal to angle M. So when angle B and angle M are equal, when angle E and angle M are equal, they form a pair of corresponding angles. So angle E and angle M form a pair of corresponding angles. Okay, what are corresponding angles? See, in a parallel lines, this angle is equal to this angle. So these are called corresponding angles. Okay, so they form a pair of corresponding angles. What does it imply? It implies that EF is parallel to MN. EF is parallel to MN. When EF is parallel to MN, we already know, that in the previous theorem we have seen that dm by ME is equal to dN by NF. Okay, and I'll just reverse it to write. I'll just write it as ME by dm is equal to NF by dN. Okay, now I'm adding one at both the places. I'm adding one here, one here. So it becomes dm plus ME by dm is equal to NF plus dN by dN. So what does it implies? dm plus ME. What is dm plus ME? dm plus ME is dE. So I can say dE divided by dm is equal to, what is dN plus NF? dN plus NF. It comes as dF divided by dN. Okay. But we know that dm is equal to AB. dm is equal to AB. So what we can say? What we can say here? What we can say here is that DE divided by, instead of dm, we are writing AB is equal to df divided by AC. Okay. So this is what you have to prove. So see, it's a reverse of that which you have proved. And similarly, this will be equal to EF by BC. Okay. So we have proved this point. Now coming to one more thing which I want to tell you, that in case, so this is what we have proved is if three angles are equal. If three angles are equal, but even if the three angles are not equal, even if we know that their two angles are equal, even then those two triangles will be similar. The sum of three angles will be 180. The sum of three angles will come out to be 180 for sure. So if two angles are equal, the third angle will definitely be equal. Okay. So if three angles are equal, their triangles are similar. Even if two angles are similar or not. If two angles are equal, it's similar. If three angles are equal, it's still similar. Okay. So coming to the next question. This is also a theorem. If in two triangles, sides of one triangle are proportional to the sides of other triangle, then their corresponding angles are equal, and hence the two triangles are similar. Okay. So what they're saying is that there are two triangles ABC and DEF. These are two triangles in which their sides are proportional. That means AB by DE is equal to AC by DF is equal to BC by EF. This is given to us. And we need to prove that triangle ABC is similar to triangle DEF. This is what we have to prove. So when we have to prove this, what does it mean? See, for any triangles to be similar, their sides are to be proportional and their angles are to be equal. So that means we have to prove now, because sides are already proportional. So we have to prove that this angle is equal to this angle is equal to this angle, and the third angle should be equal to the third angle. This is what we have to prove. Then only we can say that ABC triangle is similar to triangle DEF. Okay. To arrive at, we have to make some construction. So let's make that construction. So I'm putting one point here and another point here and marking them as M and N. Okay. So what are these points? These points are, so I'm saying DM I have taken is equal to AB. Okay. And DN I have taken equal to AC. Okay. Construction. So this is what we have constructed, and we have joined these 2 points. Okay. Now we know that AB is equal to DM and AC is equal to DN. And we don't know that MN is currently equal to BC or not. We don't know that. Okay. Now, thing is already given. AB by DE is equal to AC by DF. Okay. This part is already given. When this part is already given, and we know that AB is equal to DM and AC is equal to DN. So I can write that DM divided by AB is equal to DN I just cancel it out. So we can write it that AB by DE. Okay, so AB by DE is equal to AC by DF. This is given. This is given. So from here, we can write, instead of AB, I'm writing DM. DM by DE is equal to DN by F. Okay. So dm by de is equal to dn by df. Okay. So now I'm reversing there. So I'm just taking a reciprocal on both the sides. So what it becomes? It becomes de by dm. This implies de by dm equal to df divided by dn. Okay. Now I'm subtracting one from both the sides. I'm subtracting one from both the sides. So it becomes de by dm minus 1 equal to df by dn minus 1. So this becomes d minus dm by dm is equal to df minus dn divided by dn. What is d by dm? d minus dm. So this implies that me d minus dm is me divided by dm is equal to nf df minus dn. So df minus dn is nf divided by dn. Now I'm reversing it again. When I reverse it again, what happens? It becomes dm divided by me is equal to dn divided by nf. Now, what does it mean? dm divided by me is equal to dn divided by nf. That means that this mn line is dividing dm and dn in the same ratio. And by the theorem 6.1, I believe, it says that in case a line divides two sides of a triangle in the same ratio, that means this line is parallel to the third line. So here we proved that line MN is parallel to line EF of the triangle. Line MN is parallel to line EF of the triangle. What does that imply when these two lines are parallel? If these two lines are parallel, I can say that angle 1, okay, angle M, I'll consider this angle 1 and I'll say this is angle 2. So this implies that angle 1 is equal to angle E. Angle 1 is equal to angle E. Angle E is this angle. Okay. Why? Corresponding angles. Corresponding angles. Okay. And similarly, angle 2 is equal to angle F. Angle 2 is equal to angle F. Same corresponding angles. Now, because for triangle DMN and DEF, for triangle DMN and triangle DEF, we know that their three angles are equal. For DMN and DEF, the three angles are equal. So this angle E is equal to angle 1, angle F is equal to angle 2, and third angle is equal to third angle. That means these two triangles are similar. Angle DMN is similar to triangle DEF, okay, as we have proved in the AAA theorem. Now these two triangles are similar. When these two triangles are similar, so I can say triangle DMN and DF, triangle DMN is similar to triangle DMN is similar to triangle DEF. DEF. Triangle DEF. So these two triangles are similar. The smaller triangle, this triangle this triangle is similar to the bigger triangle. Now, if these two triangles are similar, what does it imply? It implies that dm by de is equal to dn by df, that is equal to mn by ef. Okay, so now what we are doing is, now we are reversing it. Now we are reversing it. Instead of dm, I'm going to write ab. Okay, so I'll write it as ab by de is equal to, instead of dn, I'm going to write ac by df, and that is equal to mn by ef. Okay, but we also know that ac by df also is equal to bc by ef. Okay, so mn by ef is also equal to bc by ef. So this concludes that mn by ef is equal to bc by ef. What does this imply? What does it imply? It implies, by, if I look at this, it implies that mn is equal to bc. So we have proved that mn is equal to bc. This is what we have implied. Now, when it has implied this, okay, we know that AP is equal to dm, AC is equal to dn, and mn is equal to bc. Now, that means triangle ABC is congruent to triangle DMN by SSS congruency rule. Congruency rule. Okay, so these two triangles are congruent. If these two triangles are congruent, so what we can say, and we have already proved that triangle DMN is similar to triangle DEF. So that means triangle DEF is similar to triangle ABC. Hence proved. मजा आता है जब बाद में लिखना पड़ता है hence proved. जब ये लिखना होता है ना hence proved, तब सबसे अच्छा लगता है. Okay, so this part clears it up. So coming to the next question. It says that if one angle of a triangle is equal to one angle of another triangle, and the sides including these angles are proportional, then the two triangles are similar. Okay, so this is the SAS similarity rule. Let's go through. Okay, they have given, okay, we have two triangles. I'll just name it as ABC and this triangle as DEF. Okay, first thing is, what is given to us? Given is angle A is equal to angle D. So one angle is equal, given. The one given, I should write like this. Okay, angle A is equal to angle D. This is given to us. And AB by DE is equal to AC by DF. This is given to us, these two things. Now, like the same other questions, what we did, we chose 2 points here and draw this line, so that write it as M and N. So we mentioned that DM is equal to AB and DN equals to AC. We constructed like this and we joined the lines. So in triangle ABC, in triangle ABC and triangle DMN. Okay, ABC and DMN. We know AC is equal to AC, I've mentioned. So, okay, AC is equal to DN and AB equals to DM and angle A is equal to angle D. So, these two triangles, so triangle ABC, triangle ABC and triangle DMN are congruent by SAS congruency. So these two triangles are congruent. That means ABC triangle is exactly same as DMN triangle. Okay, this part is already proved now. So that means angle B is equal to angle M and angle C is equal to angle N. Okay, this part is clear. Now, we also know that AB by DE is equal to AC by DF. So instead of AB, we can write DM. We can write DM by DE is equal to DN by DF. Okay. And again, we'll do the same thing. We'll reverse it. So it will become DE by DM is equal to DF by DN. So we reversed it. Okay. And then we'll subtract one from both. So we'll subtract implies I can write DE by DM minus 1 equals to DF by DN minus 1. Okay. What does it imply? It implies DE minus DM, DE minus DM by DM equals DF minus DN. DF minus DN by DN. Now we know DE minus DM. What is DE minus DM? DE minus DM is EM. So it implies that EM divided by DM is equal to NF DF minus DN. DF minus DN is NF by DN. And now again I'm reversing it. So it becomes DM by ME is equal to DN by NF. So we are saying that this divided by this is equal to this divided by this. What does it mean? It means that this line MN is dividing it into two proportions, to two equal proportions. And that implies that line MN is parallel to EF. MN is parallel to EF. If MN is parallel to EF, what does it imply? It implies that this angle, angle E, just here. So when MN is parallel to EF, this implies that angle E is equal to angle M and angle N is equal to angle F. So this angle is equal to this angle and this angle is equal to this angle. This implies that. So we can say that triangle DMN is similar to triangle DEF. Okay, as all three angles are equal. So angle E is equal to angle M, angle N is equal to angle F, and angle angle D is equal to angle D, common. So this angle is common. Okay, but triangle DMN is congruent to triangle ABC. So what we can say? This implies that triangle ABC is similar to triangle DEF. Hence proved. Okay. So coming to the next question. Okay, okay. So this is a simple question now. These two triangles are similar. Now, if these two triangles are similar, we have to tell what is the value of the question mark here. So we can say this is 3, and 3 times 3 is 9. This is 5. 3 times 3 is 5 is 9. So 4 3s are. So this value should be 12. And how do we find that? Because we know that the sides are proportional in similar triangles. Okay, coming to the next question. Okay, now we have into NCERT exercise 1. Fill in the blanks using the correct word in the brackets. All circles are. So there could be one circle which is small. There could be other circle which could be big. Okay, are they congruent? No, they are not congruent. Why? Because they are not exactly same. Okay, but they are similar. So answer is similar. Coming to the next question. All squares are. Again, the same thing. One square could be small. One square could be big. So all squares are again similar. See, these are 1 marker questions which can come in exam, or 1 marker or a half marker question which can come in exam. So please be cautious on these things. Please understand what is similar, what is congruent. Now all dashed triangles are similar. कौन से triangle similar होते हैं? See, we have got, see, isosceles triangle could be like this. Isosceles triangle could be this. Okay, so isosceles triangle, we can't say they are similar because their sides can vary. But for equilateral triangles, so there could be a small equilateral triangle, there could be a big equilateral triangle, and all equilateral triangles will have, as the side will be same, they will be, all equilateral triangles will be similar. So you can say equilateral. Equilateral triangles are similar, not congruent. They're similar. So please remember that all circles are similar, all squares are similar, all equilateral triangles are similar. Okay, next question. Two polygons of same number of sides are similar if their corresponding angles are the angles for a polygon. Okay, if I say this is a polygon of 5-sided figure, and this is another polygon of 5-sided figure, when are they similar? Two polygons same number are similar. When can they be similar? When their all angles are equal. All angles are corresponding angles, not all angles. Corresponding angles are equal. That means first angle is equal to first angle. Second angle is equal to second angle. So 1, 1, 2, 2. So the corresponding angles are equal, and the corresponding sides are proportional. Okay, it's proportional. Corresponding sides are proportional. Coming to the next question. What is the question? State whether the following quadrilaterals are similar or not. They see this side. Okay, what are the two things which are required? The two things required. The first thing is required is sides should be proportional. Should be proportional. And second thing is angles should be equal. Equal. So these two things which are required. So in this case, the sides are proportional, but angles are not equal. When angles are not equal, that means these are not similar. They are not similar. Okay, coming to the next question. Okay, in figure, DE is parallel to BC. Okay, DE is parallel to BC. And we have to find EC. Okay, in the first one, we have to find EC. We know that AD divided by DB, when the line is parallel, AD divided by DB is equal to AE divided by EC. So we can say 1.5 divided by 3 should be equal to 1 divided by, if so this value is x. So what is the value of x? X is equal to, if we cross multiply, it comes out to be 3 divided by 1.5. It comes out to be 2. So this value is 2. Okay. Now, the other one where we have to find AD. So for finding AD, it's the same thing. We can say AD divided by DB should be equal to AE divided by EC. Now putting the values. So we'll say AD divided by 7.2 should be equal to 1.8 divided by 5.4. So AD should be equal to 1.8 into 7.2 divided by 5.4. Now we have to do all kata PTs and then we'll do. Okay, let's divide it by 6. 6 was point will be cancelled out by point. So 6 9s are 54, 6 12s are 3 3s are 3 4s are, and 3 0.6 are. So it becomes 4 6 are 24. This is 2.4. So this side comes out to be 2.4 centimeter. 2.4 centimeter. If the calculation is correct. Okay, coming to the next question. What does this question say? EF are the points on the side PQ and PR respectively of the triangle PQR. Let me just check whether there's a figure which is given. No, there's no figure, so I have to draw the figure. E and F are the points on the sides PQ and PR respectively of the triangle PQR. So let me draw a triangle PQR. This is P, this is Q, and this is R. Now, E and F, this point is E, and this point is F. We'll join it. E and F are the points on the side PQ and PR respectively of triangle PQR. For each of the following cases, state whether EF is parallel to QR or not. Okay, so we need to check whether EF is parallel to QR or not. So EF is parallel to QR only when PE divided by EQ should be equal to PF divided by FR. Okay, this is the condition. Now let's put the value 3.9 by EQ. 3, is it equal to? We're checking whether it is equal to PF. This is 3.6 divided by FR 2.4. So 3 13s are. Okay, so 1.3s are is, let's cancel it out. So 12 2s are 12 3s are. It becomes 1.5. So it is 1.3 is not equal to 1.5. That means EF is not, EF is not parallel to QR. EF is not parallel to QR in the first case. Coming to the second case. Again, we'll do the same thing. We'll make a triangle. And these are the 2 points. P, Q, and PR. Okay, this is E and this is F. Again, we'll check the same thing. P is given as 4. QE is given as 4.5. PF is given as 8. RF is given as 9. So again, it doesn't seem like common is 4 divided by 4.5 is actually not equal to 8 divided by 9. So again, in this case, the lines are not parallel. ENF. So again, this is not parallel. Not parallel. Not parallel. Okay. Again, we'll take another. So we make triangle PQR. And again, put a line here. This is E and F. Here you've given PQ. In the previous question, what they are given? PE and QE. PF and RF. Okay. So in this question, they have given PQ. PQ, okay. They have given complete PQ is 1.28 centimeter. This entire thing is 1.28. And they have given PR as 2.56. 2.56. Then they have given PE as 0.18. Okay. This is 0.18. So if this is 0.18, what is this left? It becomes 1.10. This is 1.10. And they have given PF. PF is given 0.36. 0.36. This is 0.36. So this value becomes 2.20. So they want, now we have to check again. So PE divided by EQ, is it equal to PF by FR? So we can say 0.18 divided by 1.10, is it equal to 0.36 divided by 2.2? Yes, it is equal. See, 18 to the 36, 1.12 is 2.2. So yes, they are proportionate. So EF is parallel to QR. Okay. So coming to the next question. If LM is parallel to CB, okay, where is LM? LM is parallel to CB. Good. And LN is parallel to CD. Then we have to prove AM by AN, AM by AN, AM by AN is equal to AB by AD. Okay. So let's see. In triangle ABC. So first we are checking triangle ABC. Okay. Because these lines are ML is parallel to BC, we know that AM by MB now we should actually directly take it. Okay. Because these two triangles are similar, I can say this divided by this is equal to this divided by this. I can directly say that actually. Okay, we have proved, we have some questions, we have proved it. Okay, so let's say AM by AB should be equal to AL by AC. Okay, this is first equation. Now from triangle, in triangle ADC, we can say that AN divided by AD should be equal to AL divided by AC. This is L and this is C. Okay. See, from 1 and 2, if you see AL and AC and AL and AC, both are common. So what does it mean? That means AM by AB is equal to AN divided by AD. Now we cross multiply this, we'll move this side and we'll move AB this side. So that implies AM divided by AN equals to AB divided by AD. Hence, proved. Okay, so coming to the next question, it says in figure DE is parallel to EC. Okay, when you say DE, this line is parallel to AC, not EC, AC. DE is parallel to AC. So when DE is parallel to AC, so I can say that BD divided by AD, BD divided by AD or BD divided by DA should be equal to BE divided by EC. Okay, this is as per the theorem. As per the theorem. So you have to write the theorem as per the theorem. Okay, you have to write the theorem. I'm not writing it here, but you have to write it. Now, so BD divided by DA should be equal to BE divided by EC. Okay. Now, they've also given that DF is parallel to AE. So DF is parallel to AE. So if DF is parallel to AE, so in triangle ABC, so DF is parallel to AE. So in triangle ABE. Okay, look at the triangle ABE. In ABE triangle, BD divided by AD is equal to BF divided by FE. Okay. Now, we know this is equation 1 and this is equation 2. Okay, this is also by the theorem that if a line is parallel, then it divides the other two sides of the triangle in the same ratio. Now, this is from 1 and 2. From 1 and 2, we can say, because this is BD is equal to BD by AD. This is also BD by AD. So BD by AD is equal to BE by EC, and BD by AD is equal to BF by FE. So we can say that BE divided by EC should be equal to BF divided by FE. So we have to prove BF by BE. We have to prove BF by BE. So just cross multiply. I'm just taking BE this side and I'm taking FE this side. So it becomes FE divided by EC should be equal to BF divided by BE. Okay, and this is what we had to prove. Okay, so in every equation, we have to use the similar theorems. So either the theorem will be related to parallel line. So if there is a parallel line, you can say that it is dividing into two equal parts. Okay, you have to use that that theorem to answer the questions. Okay, so coming to next one. In figure, DE is parallel to OQ. So let's see, where is D? DE is parallel to OQ. Okay, so now you can see this triangle PQO. So in triangle PQO, ED is parallel to QO. Therefore, PE divided by EQ should be equal to PD divided by DO. Yes or no? This is by theorem 6.1. Theorem 6.1, theorem 6.2. THEOREM 6.2. Theorem 6.2. Okay, when the line is parallel, it divides the theorem 6.1. Sorry, my mistake. Theorem 6.1. So you don't have to write theorem 6.1. You have to write the entire theorem. Please don't write theorem 6.1. Please write the entire theorem. Okay, that if a line is parallel to one line of a triangle, one side of a triangle, then it divides the other two sides in the same ratio. Okay. Okay, then DF is parallel to OR. DF is parallel to OR. So we'll take triangle POR. So in triangle POR, DF is parallel to OR. So what is going to happen now? The PD divided by DO should be equal to PF divided by FR. Okay, now you see, this is also PD by DO. This is also PD by DO. If I take this as equation 1, and this is equation 2. So from 1 and 2, from 1 and 2, we can say that PE divided by EQ should be equal to PD divided by DO, right? PE divided by EQ. So PE divided by EQ should be equal to PF. So we have to write this one, sorry, is equal to PF divided by FR. So it becomes PF divided by FR. So P divided by EQ is equal to PF divided by FR. Because it is same by 6 points, I'll just write it again. P divided by EQ is equal to PF divided by FR. That means because a line which divides the triangle into two similar ratios, a line which divides into two equal ratios in a triangle. So this line will be parallel to the third side of the triangle. So in this case, when we say this divided by this is equal to this divided by this implies that EF is parallel to QR. So this is hence proved. Okay. So coming to the next question now. So this question will also be similar. Okay. Now in figure A, B, and C. So in figure A, B, and C are the points on OP. Okay, OP. Okay, OP, OQ, 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 and OR respectively, such that AB is parallel to BQ. Now AB is parallel to PQ. Okay, if AB is parallel to PQ, so in case one line is parallel, what does it mean? So I'll just say in triangle POQ, AB is parallel to PQ. If AB is parallel to PQ, what does it mean? That means OA divided by AP, OA divided by AP is equal to OB divided by BQ. Okay, this is first equation. And this is by theorem 6.1. Now, on the other side, they've mentioned that ABC, AB is parallel to PQ, and the second one was AC is parallel to PR. So AC, this line, AC is parallel to PR. So I'll say in triangle OPR, AC is parallel to PR. And because AC is parallel to PR, OA divided by OAP, OA divided by AP is equal to OC divided by CR. Okay. Now see, it is OA divided by AP, and here also it's OA divided by AP. So we can say from 1 and 2, from these two equations, I can say that OB divided by BQ should be equal to OC divided by CR. That means OB divided by BQ is equal to OC divided by CR. Okay. And because this is same, by 6.2 theorem, we can say that BC is parallel to QR. Okay. Using theorem 6.2. Line which divides a triangle into two equal parts, the two sides of the triangle in the same ratio, that line is parallel to the third side of the triangle. Okay. So coming to the next question now. Okay, now ABCD is a trapezium in which AB is parallel to DC. Okay, AB CD is a trapezium. So let me just say AB is parallel to DC. So I just say A, B, C, and D. This is A, this is B, C, and D. So AB is parallel to DC. AB is parallel to DC. And its diagonals intersect each other at O. So let's make the diagonals. Diagonal. This is first diagonal, and this is the second diagonal. And these diagonal intersect at point O. Now you have to prove AO by OC, AO by CO is equal to OD by DO. Okay. Now look at triangle AOB and triangle DOC. So DOC and AOB. Let's look at these two triangles. I'll just say right triangle. This angle is equal to this angle. Yes or no? Angle AOB is equal to angle DOC. Okay, this is vertically opposite angles. Now, I also know that angle 1, which is marked here, angle 1 is equal to angle 2. Okay, what is angle 1? Angle BAO, or I can say BAO. Okay, this is angle BAO. And what is angle 2? Angle 2 is DCO. Angle DCO. Okay, why they are equal? You have to mention. These are the alternate interior angles. These are alternate interior angles. Alternate interior angles. So alternate interior angles, so wherever there are two lines are parallel and this one transversal of that, this angle is equal to this angle. Okay, so this is called alternate interior angle. So we can see that AB is parallel because AB is parallel to CD. You can write AB is parallel to CD. Now similarly, angle 3 is equal to angle 4. Angle 3 is equal to angle 4. It's by same interior angles. Okay. Now we can see that triangle AOB is similar to triangle DOC. Sorry, AOB. So we started with 1. 1 is equal to 2. So I should write CDO or COD. COD. So triangle AOB is similar to triangle COD. Okay. First, so when I chose A, what is A? A angle is between 3. So I just, so this angle is equal to this angle. So basically A angle is equal to C angle. So A, C. Now B angle is equal to D angle. So B and D, and B middle comes the O. So AOB is similar to COD. Okay. If AOB is similar to COD, what does it mean? I can say OA, sorry, or AO divided by OC, sorry, CO should be equal to, you take BO divided by DO. Okay, triangles are similar. See, these sides of similar triangles. So this is similar. Why it is similar? First of all, by AAA similarity rule. A similarity rule. This is similar because of AAA similarity rule. Okay, and these. So you have to write the theorem again. Okay, why it is AO? So you can say sides of similar triangles are in proportion. Okay, coming to the next question now. The diagonals of an equilateral quadrilateral ABCD intersect each other at a point O. So they are diagonals of a quadrilateral ABCD. I'll just make a diagonal. This is the diagonal. Okay, I've not made things parallel. Okay, little bit pyramid I made. I'll just write it as A, B, C, and D. So diagonal ABCD intersect each other at O. So this is the intersect at O. So these are intersecting at O. Good. And they have mentioned AO by CO. This is given AO by CO is equal to BO by DO. So AO by CO is equal to BO by DO. Okay. So this is given already. Show that ABCD is a trapezium. So we have to prove that it's a trapezium. We have to prove it's a trapezium. So that means to prove it's a trapezium. So how does trapezium differ from any other quadrilateral? In that AB, we have to prove that AB is parallel to DC. So if we can prove that AB is parallel to DC, that means it's a trapezium. Got it? Now, how will you prove it? Now we know that AO by CO is equal to BO by DO. And we also know that angle O is equal to angle O, vertically opposite angle. So this is side is similar to side. This side is similar to, this side is proportionate to this side. Okay. And this side is proportionate to, so they're opposite sides. So this side is proportionate to this side. This side is proportionate to this side. And the angle between those is equal. So that means triangle. So we have to write all these things. Okay. So this, I'll just write it so that remember AO by CO is equal to BO by DO. Okay. And it is given. And angle AOB is equal to angle COD. Angle AOB is equal to angle COD by vertically opposite angle. So what does this imply? This implies this triangle AOB is similar to triangle DOC. This implies that both the triangles are similar. By which rule? Tell me. By SAS similarity rule. By SAS similarity conditions. Side. So this is side, angle, and then side. Then again side, angle, and then side. Okay, so coming to the next one. In figure, PQ is parallel to RS. Okay, this line PQ is parallel to RS. Okay, prove that triangle POQ is similar to triangle SOR. Okay, so how to prove it? Now we know that this angle is equal to this angle. This is one, this is one. Yes or no? Yes. Why? Because they are vertically opposite angles. Now second angle is equal to second angle. Why? Because vertically opposite angles. Third angle is equal to third angle. So that means both the triangles are similar by AA similarity. By AA similarity. And in the previous, okay, these two triangles, this one and this one, are similar by AA similarity. So it was a very simple kind of a question, which is given as an example. So we'll pick a lot more examples to practice. So I'm not doing anything here. I just told you this, that this side, sorry, this angle is equal to this angle. This angle is equal to this angle, and third angle is equal to third angle. That means these two triangles are similar because of AA similarity. So POQ is similar to an triangle SOR. Coming to next. Observe the figure and find angle P. You have to find the angle P. Okay. Now, first we have to find out which the triangle, the similarity, where exactly they are similar. So we'll see this is 3.8. Now 3.8 and this is 7.6. So we'll say AB, the proportion with, okay, this is with 80 angle with 60 angle. So how will we write AB by RQ? AB by RQ or maybe QR. So we don't know what is that as of now. First, we'll check with 6. Now, 6. So when I'm saying from B to C, B to C. So it's 6 and this is 12. So I can write BC, not, yeah, BC. From AB I've taken and then I'm taking BC divided by BC divided by PQ. BC divided by PQ. Actually, we should have taken QP. Should have taken QP here. Okay, because so now we have to find out which angles are these. Which angles are these? So 3.8 is this one. Double of it. This. So I'll say this is one side. This is second side. So this is one side and this is second side. And in between the angle is 60. So that means this angle is equal to 60. So I can say angle Q is equal to 60 degree. This part is clear? Okay. Now we know this is side 3. So we can say between 2 and 3. This is side 3 here. So between 2 and 3. So if we have to find the 6, basically 6, the angle between 2 and 3. The angle between 2 and 3. So we know this angle or not? This is 60. This is 80. So 60 plus 80. 60 plus 40, 100, 140. So this angle should come out to be 40. Yes or no? Because the sum of all 3 angles should be 180. Now this is 60, 40. So angle between 2 and 3 is 40. Angle between side 2 and side 3 is, this should be 40 degrees. And what's the third angle left? It's 80 degrees. So now we know the angles here. Okay, coming to the next one. In the given figure, OA multiplied by OB is equal to OC multiplied by OD. So they have mentioned OA multiplied by OB is equal to OD or OC multiplied by OD. Okay. So what we are doing it here. So it's a ratio. So let's make it as a ratio. So we'll make it as OA divided by OD. OA divided by OD should be equal to OB OA divided by OD. So OA OD. I just move it out here. OA divided by OD is equal to OC divided by OB. Okay. And this angle is equal to this angle. So angle AOD is equal to angle COD. Okay. So when these side sides are in proportion and this is equal, so triangle AOD is similar to triangle COB by SAS similarity. Oh, my writing is so bad. By SAS similarity. Now if these two triangles are similar, what does that mean? That means angle A is equal to angle C, angle B is equal to angle D, and third angle is equal to third angle. So we have to find angle A is equal to angle C. Angle A is equal to angle C. Angle B is equal to angle, hence proved. Okay, so coming to this question, a girl of height 90 centimeter is walking away from the base of a lamp post at the speed of 1.2 meter per second. If the lamp is 3.6 meter above the ground, find the length of a shadow after 4 seconds. Okay, let's draw the figure. The lamp is 3.6 meter high. So let's draw a lamp. This is the lamp. which is 3.6 meter. The line is not very straight, but anyways, or we'll just correct it one more time. This is the lamp. This is 3.6 meter high. This is the ground. Okay, this is 3.6 meter high, 3.6. And there's a girl who's standing here, just 90 centimeter, 9 fours or so, somewhere around this height. 90 centimeter girl is standing here. She's standing over. Okay. Okay, so the girl is standing here. And then she starts walking away from the pole. And she walks in this direction. And she walks for 4 seconds. She walks for 4 seconds. Now, after walking for 4 seconds, we have to first find out how much distance she must have covered. So we know distance is equal to speed into time. So what was speed? Speed was 1.2 meter per second. So 1.2 meter per second multiplied by time is 4 seconds. So it becomes 4.8 meters. So she has gone 4.8 meters away. So now she's standing here now. Say this is 4.8 meters. Let's say this distance is 4.8 meters. And now the girl is standing here. Girl, I just make it. When we were kids, the drawing looks so nice. Ting, 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 ting. And she's wearing skirt. Look at to show it is she's a girl. Okay, my drawing is bad, so please don't mind that. Okay, girls, especially, please don't mind that. Okay, so the girl is standing here now, 4.8 meters away. Now, from the lamp post, we have to find her shadow, just touch. So it's kind of touch here. So her shadow distance is somewhere around, say we say X. Okay, and what is the height of the girl? The girl's height is 0.9. I'll just say 0.9. Okay, that's the height of the girl, 0.9. Now, because we know this triangle, I'll just write A, B, C, and M, N. So we can say triangle ABC is similar to triangle MNC. Why? Because this angle is 90 degree. This angle is also 90 degree. And this is vertical. Vertical means 90 degrees. So this angle is equal to this angle, and angle C is common. So we can mention that triangle ABC is similar to triangle MNC. And when the triangles are similar, what happens? What happens? That these sides are proportional. Okay. So this is one side. So I'll write, and this is one side. So I'll just say the side 3.6 divided by 0.9 should be equal to the full side. It is 4.8 plus X divided by the smaller side, the small triangle side. Okay, so it comes out to be 4 is equal to 4.8 plus X divided by X. So it becomes 4X is equal to 4.8 plus X. So X goes to the other side. It becomes 3X is equal to 4.8, and X is equal to 4.8 divided by 3. 3 ones are 3 and 3 6 are 18. So 1.6 meters. So the value of X comes out to be 1.6 meters. Please, my drawing is bad, so please don't mind that. But I believe I clarified the question. Okay. So the shadow length is 1.6 meters. Okay. So coming to the next question. CM and RN are respectively the medians of triangle ABC and PQR. Okay, CM. So this is a median. What is a median? The median is which divides the other side of the triangle into two equal parts. So this side is equal to this side. So we can say AM is equal to MB. And similarly, RN is a median. So QN, this part is equal to NP. Okay, so I'll just write it as AM is equal to B and Qn is equal to NP. Okay, this is given to us. And we have, it's also given that medians of triangle ABC, and we have also, it's also given that ABC is similar to PQR. So if ABC is similar to PQR, that means the sides are in proportion. The sides are in proportion and the angles are equal. So let's, when the sides are in proportion, we can write that AB, so A is the first mention, okay? AB is equal to PQ, yes, AB divided by, not equal to, okay, the proportion of AB and PQ. AB divided by PQ is equal to BC divided by QR is equal to CA divided by RP. Okay, this is given because these two triangles are similar. Okay, now what we have to prove? Triangle AMC. Okay, this triangle is similar to triangle PNR. So let's compare these triangles. Okay, so in triangle AMC and triangle PNR, I can say that angle A is equal to angle P. Why it is? Because when the triangles are similar, we can say here that angle A is equal to angle P, angle P is equal to angle Q, and angle C is equal to angle R. So we'll require only this part, so which we have already taken here. So this is given as triangle ABC is similar to triangle PQR. Okay, this part is already given. Now, we also know that AB divided by PQ is equal to CA divided by RP. CA divided by RP. Okay, so we have mentioned it. AB by PQ is equal to CA by RP. Okay, why we have taken these parts? Because these are the parts of these triangles. Okay, now I'm dividing this entire equation, the numerator and the denominator, by half. So I'll just write half of AB divided by half of PQ is equal to CA by RP. So when I say half of AB, what is half of AB? Because M is the median, so I can say half of AB is AM. So this implies that AM by PN is equal to CA by RP. Okay, so this is second and this was first. So by first and second, we can say that triangle AMC and triangle PNR are similar. Why they are similar now? By which rule? It is by SAS similarity rule. Similarity. Okay, what does SAS similarity rule says? It says that the two sides, so we have this side is proportional to this side. We have mentioned AC by RP. AC by RP. So this side is proportional to this side, and this side is proportionate to this side. Okay, these two sides are proportional and the angle between those is equal. So when two sides of the triangle are proportional and the angle between those sides is equal, they are similar by SAS similarity. Okay, so let's come to the next question. Wow, now the exercise. It's the last exercise of your triangles. Let's do it well. State which pair of triangles in figure 6.34 are similar. So we have to find out which are similar. Write the similarity criteria used by you for answering the question, and also write the pair of similar triangles in the symbolic form. Okay, first of all, let's find out which are similar or not. So I'll say this angle is 40. This angle is 40. Okay, all the three angles should be equal. This angle is 60. This angle is 60. This angle is 80. And this angle is also 80. Okay, so 40, 60, 80, 40, 60, 80. So all the three angles are equal. So they are similar by AAA similarity rule. These are similar. Let's find the other one. So this side is 2. Okay, and its proportionate side, we can see all three sides. This is the proportionate side of 2. So we can say 2 by 4 is equal to, we can say this side 3 by 6, and that is equal to 2.5 by 5. So it is 1 by 2, 1 by 2, or 1 by 2. That means this triangle is similar. Let me check whether they are correct. Okay, 2, then 3, and then 2, and then this, and then this. Yes, so these are similar. Now coming to the next one. So, okay, why they are similar? By we have to write that also. Why they are similar? I did not mention it. They are similar by SSS similarity rule. Okay, all sides are proportionate to the other sides of the triangle. Now coming to this, let's compare. This is 2, and I'll compare it with 4. So it's say MP 2 by 4. Okay, then comes 3 by 6 is equal to 3 by 6. Good, but is not equal to 2.7 divided by 5. So unfortunately, this is not similar. This is not similar. Okay, let's find the other one. So we are saying side 2.5. What is similar side? We'll consider this as a similar side because 2.5, 2 is a 5. We could have taken 5, 5 also, but okay. So 2, it's got 2 times. Okay. Then we have this side is 5. This side is 10. This is similar. And between 2.5 and 5, there's an angle of 70 degree. Between 2.5 and 5, 70 degree. And this is 5 and 10. This is 70 degree. So yes, this triangle is similar. And why they are similar? By side. So I can say MN by PQ. MN by PQ. MN. Oh, sorry. I should write NM. I should write NM actually. NM by PQ. Okay, because it's coming towards 70 degree. It's coming towards 70 degree. So NM instead of MN. NM by PQ. PQ. So is equal to RQ. Not RQ, first I have to write from this side. LM or ML by from 70 to other side. So from 70 QR. QR. So we're saying two sides are proportionate and the angle between them is same. So these two are similar by SAS, side angle side similarity. NCERT वाले बड़े बढ़िया होते हैं. देखियो, they have given one A, they have given one SSS, they have given one SAS. Let's find out this one. Now we'll say it's 2.5. This is 5. Good. This is 3. This is 6. And the angle between 5 and 6. The angle between 5 and 6 is 80 in this triangle. But the angle between this and this is not 80. It's not 80. If this angle would have been 80, if this angle would have been 80, okay, then these two triangles could have been similar. But from here, we cannot find out. From here, we cannot find out. If this side is also 6, see, if this side is also 6, if this side is also 6 and this angle is also 80, then we can say. But as of now, with the current information which we have, we cannot say that these triangles are similar. Why? Because the angle between 3, here it is the angle between 3 and 2.5. We don't know what is the angle. Here between 5 and 6, the proportional side, it's 80. So here we know it is 80. Here between 2.5 and the other side, it is 80. So we can't say, okay, what angle is this one. So we don't know. If we would have known that this angle is 80, then they would have been similar. But as of now, we don't know. So this is not similar. Okay, now coming to the next question. So this is 70, 80. What is the third angle here? If it is 70, 80, the third angle will be 70 plus 80, 150. This angle which comes out to be 30. So I'll just say this is 30, 70, and this angle comes out to be 70. Any which ways, because two angles, now the two angles are same. You can say 80, 30, here also 80, 30. So that means these two triangles are similar by AA similarity. AA similarity, or we can say AAA similarity. These two triangles are similar. Okay, so coming to next question. In figure 6.35, 6.35 figure is there. Yes. ODC is similar to OBA. ODC. Okay. So ODC is similar to OBA. Okay. So I can say that this angle is 70, and because these are already similar, so I can say this angle is also 70. Okay. If this is 125, the remaining angle remains as 55, because this is the straight line, 55 plus. So if this is 55, this is 70, this angle comes out to be 70 plus 55 is 125. 125. Okay, and which is 125. If it is 125, then this angle is also 55. If this is 55, this angle is also 55. If this is 125, this is also 55. Okay, now we have to find angle DOC. DOC. DOC we could have found without the similar triangles also. It's like sum of the two angles should be 180. The DOB is the complete angle is 180, 125, 180 minus 125. This is what you would find out. Oh my goodness. Angle DCO. DCO, that is also 55. 55, 55, 110 and then 70. And OAB. OAB is also 55. I don't know how it is related to similar triangles. Anyways, this is related to, we can do it through similar triangles, but it is easier done through normal way, because they have mentioned the two lines are parallel. They should have not mentioned the lines are parallel. Okay. Diagonal AC and BD of a trapezium ABCD with AB is parallel to DC. So let's make a trapezium first. I think we did this question somewhere. We did this question. Okay, well, let's do it again if we have done it even then. A, B, C, and D. So these two triangles are parallel. Sorry, these two, this is a trapezium where AB is parallel to DC. AB is parallel to DC, which is given. Intersect each other at O. Let's intersect it. They intersect at O. This point is the lovely point O. And we know, using the similarity criteria of two triangles, show that OA by OB is equal to OC by OD. Let's see this. So if I say that this angle is 1, this angle will also equal to 1. These are equal. Why? These are alternate interior angles. So see, I am just telling you, but you have to write it in detail. So how will you write it? Angle ABO is equal to angle ABO is angle CDO. Why? Alternate interior angles. Okay. Now, similarly, this is equal to this. The third angle is equal to this. This is, so angle 2 is equal to angle 2, but this is alternate interior angles. Then this angle DOC is equal to BOA, that is vertically opposite angles. So now this angle is 3, this is also 3. So by A similarity, this triangle is similar to this triangle. Now when those triangles are similar, let's find out the ratios of it. Now we have to find out, see 1 and 3. What is the line between 1 and 3? BO. I'll write BO between 1 and 3. So which side, the 1 and 3 is DO here. DO. Okay. 3 and 2. OA. 3 and 2 here it is OC. And comes 2 and 1. 2 and 1 is AB. 2 and 1 CD. Okay. So this comes. Now what we have to prove? We have to prove OA by OB. OA by OB. So let's take this part. This is something which we require. So this is like a complete, this is the complete fruit. Okay, this is a complete fruit. But this is something which you don't require as of now. This is the seed, you can say. We don't require it currently. So we require only the important part from which we'll get the answer. So we know that BO by DO is equal to OA by OC. Okay, so I'll just cross multiply. So I'm just taking OB this side and I'm taking DO on this side. Not OD on the side, OA on this side. So it becomes OA divided by OB because OB has gone down, and I'm taking OC up here is equal to OC divided by OD. So this is what we had to prove. Hence proved. Hence proved. Coming to the next question. In the figure 6.3 is 6 QR by QS. This is QR. Where is QR? QR. This complete side by QS. QR by QS is equal to QT divided by PR. Oh, QT by PR. Okay. That's fine. And angle 1 is equal to angle 2. Ha 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 ha. See, when they have given that angle 1 is equal to angle 2, what does it mean? It means that PQ is equal to PR. PQ is equal to PR, right? So when PQ is equal to PR, so I can say this is already given. So instead of PR, I'll write PQ. So it becomes QR divided by QS is equal to QR divided by QS is equal to QR divided by QS is equal to QT divided by PQ. So QT divided by PQ or QP. QR divided by QS is equal to QT divided by QP. I'll write QP. Okay. So these sides are proportionate. So I can also, because it's complete side, this actually directly proves it. But anyways, I'll prove it in detail. For proving it in detail, what will I do? I'll write it QT minus QT minus QP. So, okay, I'm subtracting 1 from both the sides. QS. Yes, I'm subtracting 1 from both the sides. -1, -1. So when I subtract, what happens? It becomes QR minus QS divided by QS is equal to QT minus QP divided by QP. So what is QR minus QS? QR minus QS becomes SR. SR by QS. SR by QS. And what is QT minus QP? QT minus QT is PT. PT divided by QP. QP. Now, this implies, I'll just reverse it. We'll take a reciprocal. That means QS divided by SR is equal to QP divided by PT. Okay. What does it imply? It implies that line PS is parallel to TR. Why they are parallel? Because the line made parallel to one side of the, no, sorry, a line which divides the two sides of the triangle in proportion is parallel to the third side. Okay, that is the by theorem 6.2. So you don't have to write theorem 6.2, you have to write the complete theorem. Please remember that. Okay, so these two lines are parallel. If these two lines are parallel, we can say that this angle is equal to this angle, because the lines are parallel, and we can say this angle is equal to complete this angle. Okay, and third angle is any which is common. So by A similarity, these two triangles are similar. Which triangles are similar? PQS, this triangle, and the complete triangle TQR are similar by A similarity. Okay, guys, just let's do the next question. What does it say? It says that S and T are points on sides PR and QR of triangle PQR. Okay, let's make a triangle PQR. Let's clear it up. I'm making a big triangle. Let's say P, Q, and R. So PR, S and T. So I'll just say this point is S and this point is T. So S and T points. PQ. S and T are points on sides PR and QR. Oh, what am I making? QR. The point T is in QR. So I just have to clean it up. So S and T are the points on the sides PR and QR. So I'll just make a triangle PQR first. Right, that's P, Q, and R. So PR, this point is S, and QR is T. So I'll just say point T. So the figure is same. I've just changed the new numbers or changed the vertices, the name of the vertices. Now, angle P is equal to, such that angle P is equal to RTS. RTS, this angle is equal to this angle, angle P. Angle P is equal to angle RTS. This is given. Show that triangle RPQ, the complete triangle, is similar to triangle RTS. RTS. Wow. Wow. So if this angle is 1, this angle is also 1. Isn't it? They have given it. If this angle is 1, this angle is also 1. If this angle is 2, this angle is also 2. So if I make this, okay, to prove this similarity, the best thing, for not making any mistakes, we should make two triangles separately. So I'll make this triangle and the bigger triangle. Okay. So these two triangles I'm making separately. This is R, S, T, the smaller one, and this is R, P, Q. Okay. So we know that this angle 1 and P is equal to this angle, which is given. We have given that this angle is equal to this angle. So when two angles are same, when two angles of triangles are same, these two triangles are similar. By what? By A similarity. LARITY, similarity. So these two triangles are similar by A similarity. Now, please understand, if you make these two, okay, if you have to write the proportions, how will you write? So this is 1, we have mentioned. I'll just write this is 2. Now, it is easy to write proportions when you have the numbers written here. So I'll just say this is 3 and this is here, it's 3 in these two triangles. Now, what is in the smaller triangle, RST, if I have to write the angle between the line between 3 and 2 is SR. So I'll write SR divided by 3 and 2. What is it? It's QR. Okay. Now between 3 and 1, I've taken SR. So 3 and 2, I'll just say 2 and 1. So I'll just say RT. Between 2 and 1 is RT. What is between 2 and 1 here? Is RP. And then between 1 and 3 is TS. Between 1 and 3 is PQ. So we can write the proportions correctly. Else we can make mistakes. In case we are not writing this way, we can make some mistakes by somewhere writing the numbers or basically the sides incorrectly. So please mark the angles or mark the sides somewhere so that you're using the right proportions. Okay, coming to next. In this question, it is mentioned that triangle ABE is congruent to triangle ACD. So triangle ABE, this triangle is congruent to triangle ACD, this triangle. These two triangles are congruent. So if these two triangles are congruent, I'll just make these triangles separately so that you understand which side is equal to which side. I'm just making it A, B, E. And the other one was, so making these two triangles which are congruent. This is A, D, C. So from here we know that AD is equal to AE. AD is equal to AE. This side is equal to this side. And AC is equal to AB, or AB is equal to AC. AB is equal to AC. The complete sides AB and AC are equal, and we can say BE is equal to DC. Okay, so these three things which we know. We know that if AD is equal to AE, if AD is equal to AE, what does it mean? AD of this triangle is equal to AE. AD of this triangle is equal to AE. That means this angle is equal to this angle. So I'll mark these angles as 1, 1. And we also know that AB is equal to AC. AB is equal to AC. Okay, so I'll just say this angle is 2. This angle is also 2. I believe we'll be able to solve with this information itself. Now we know that in triangle ABC, if I mark this as angle 3. So I know that in triangle ABC, angle 3 plus angle 2 plus angle 2 should be equal to 180. So that angle 2. Okay, so that means 2 angle 2 is equal to 180 minus angle 3. 2 angle 2 is equal to 180 minus angle 3, or angle 2 is equal to 180 minus angle 3 divided by 2. Okay. Now I'm checking in triangle ADE. ADE, angle 3 plus angle 1 plus angle 1 should be equal to 180, or angle 3 plus 2 times angle 1 should be equal to 180. And I can say that 2 angle 1 should be equal to 180 minus angle 3, and angle 1 should be equal to 180 minus angle 3 divided by 2. So this is first equation and this is second equation. See, angle 2 and angle 1 are exactly the same. It is 180 minus angle 3 by 2, 180 minus angle 3 by 2. So angle 1 is equal to angle 2. Angle 1 is equal to angle 2. So when angle 1 is equal to angle 2, angle 1 is equal to angle 2. Here also it's angle 1 is equal to angle 2 and angle 3 is same. Then triangle ADE, triangle ADE and triangle ABC are similar by A, A similarity, because all the three angles are same. So angle ADE is equal to angle ABC. Angle AE, angle AED is equal to angle ACB, and the third angle is common. So these two triangles are congruent, not congruent, but similar by AAA similarity. Okay, so coming to the next question. In figure 6.38, altitudes AD and CE. Okay, so these are the altitudes AD and CE. Okay, these are the altitudes intersect at the point P. This is the point P where they intersect. Show that triangle AEP. We'll say AEP. I'm just making this triangle separately. So these are 4 questions. I want to do it correctly. AEP, and this is P, E, and A. AEP. Okay. It's CDP. CDP. Because this is the triangle. I just make it here separately. CDP. So here is P, D, and C. Okay. This angle is equal to this angle 90 degree each. This angle is equal to this angle. So the two angles are the same. When the two angles of this triangle are same, this triangle and this triangle, two angles are same. So these are similar by AA similarity. I think everybody will, all these questions will be similar by AA similarity. Okay, now coming to second one. ABD is similar to CBE. ABD. A, B, D. Now ABD has one angle is 90 degree. And CBE. C, B, E. Okay, I just make these triangles separately. So this is one good tactic to make this triangle separately so that you know what are you talking about. So this angle is B here. This angle is 90 degree. This is D and this is A. They are talking about ABD. So I've just made ABD separately. And on this other side, I'm making CBE. It is C, B, E. Okay, these are triangles. C, B, E. Now this angle is 90 degree and this angle is 90 degree. Then angle adjacent to it is B here and this angle adjacent. So there are two triangles which are two angles which are same, 90 and angle B. These angles are same and therefore this is also similar by AA similarity. Okay, coming to AEP. I'll just clear it up. AEP. AEP. So I'm making this triangle here itself, not making it separately. AEP and ADB. ADB, this triangle. This triangle. Okay, so I have to make it separately now for you to understand. So I'm just making the first triangle. This is A, E, P, AEP. This angle is 90 and this angle is A. And the second triangle, we have to make it like this. This is A is equal to A, and this angle is equal to 90. A, D, B. So we know that AEP is similar to ADB by AA similarity. Two angles are same. The angle A is same and the 90 degree angle is also same. So this is similar by AA similarity. Now I'll clear it up. Coming to the fourth one. Triangle PDC. What is this PDC? Oh, this small triangle. PDC. PDC. And triangle BEC. Where is B? B, E, C. This complete triangle. Okay. Now, if you look at these two triangles, I'll just make it small triangle here. This angle is 90. I'll just make C, P, D. And this is the bigger triangle like this. This is B. This is E, and this is C. Now angle C is equal to angle C, and angle E is equal to 90, and this is here angle D is equal to 90. So two angles are same. So this is also similar by AA similarity. So all these triangles are similar, and it's pretty easy to prove because all are similar by AA similarity. So coming to the next question. E is a point on the side AD produced of a parallelogram ABCD. Now there's a parallelogram ABCD, and this side is produced to a point E. B intersect CD at F. So this is the point F where it intersect CD. Show that ABE is similar to triangle CFB. ABE. Okay, this bigger triangle, I'll just make it this bigger gun-like triangle should be similar to CFB. CFB. Okay, so this triangle. Okay. Now we know that angle A is equal to angle C. Yes or no? We know it. Why? Opposite angles of a parallelogram are equal. So if this angle is 1, this angle is also 1. Okay. Then I'll just mark it. This is A, this is E, this is B, this is B, this is C, and this is F. Now we have to find out some other angles which are equal. Okay, we know that this angle is equal to this angle. Yes or no? They are alternate interior angles. See, these two lines it's a parallelogram. The opposite sides are parallel. So this angle is equal to this angle. So I'll say this angle is equal to this angle, mark it as 2. This is 2. This is 2. So I can say that by AA similarity, because two angles are same, this triangle is similar to this triangle, or triangle ABE is similar to triangle 1, 2. CBF. These are similar. Guys, you have to write all these things. I'm just telling you how it is done, but you have to write in the exam. Don't just leave it the way I'm leaving it here. Okay. So coming to the next one. In the figure 6.39, ABC and AMP are two right triangles. Okay. ABC, and AMP. Okay. Right triangle at B and M respectively prove that triangle ABC is similar to triangle AMP. Wow. So I'll just make these triangles separately, and then you can say that it will be similar. So I'm just making the triangle ABC. This is A, B, C. Now I'm making another triangle AM, B, A, M, A, M, P. Okay, angle A is equal to angle A. Yes or no? Right. It's a common angle. And this angle M is equal to 90. I'll just say 1, 1. This angle is equal to 90, and this angle here, E is also equal to 90. So by AA similarity, these are similar. AA similarity, they are similar. So I'll just mention that this is equal to third angle. If two angles are same, third angles is also same. Now coming to the second point. Second point is CA by PA is equal to BC by MP. So let's put down the ratios. If the triangles are similar, then we can say that AC, which is between 1 and 3. 1 and 3, so it's AP. Then 3 and 2. So we'll take 3 and 2. CB, PM is equal to 2, 1. So 2, 1 is BA. 2, 1 is MA. Okay. So now, let us check again. There's something wrong, I believe I've done. A is showing it many places. Okay, between 1 and 3. 1 and 3 is AC. 1 and 3 is AP. So AC by AP, this is correct. AC by AP. is equal to CB. CB is 2 and 3 by, okay, by PM, yes, is equal to BA. BA is 2, 1 is equal to by MA. MA, that's correct. Now, we have to prove CA by PA. So CA, okay, this is CA by PA. This is correct. Is equal to BC. BC by MP. MP. Oh, it's already proved here. It's already proved here. Okay, so coming to the next question. In figure 6.40, E is a point on the side CB produced of an isosceles triangle ABC. Wow, this is an isosceles triangle. So I know this angle is equal to this angle. And this complete side is equal to complete side. This angle is equal to this angle. With AB is equal to AC. Okay, if AD is perpendicular to BC and EF is perpendicular to AC, prove that ABD is similar to ECF. ABD. They want to prove that ABD, this triangle, is similar to ECF. ECF. It's similar to ECF. So I'll just make these two triangles separately. Making it separately makes it life very easy in similar triangles. Okay, this is A, B, D, and this is F, C, and this is E. Okay, so we know that this angle is equal to 90. I'll say 1, and this angle is equal to 90. I'll say 1. Now, we also know that angle B is 2. This is angle 2. When two angles are same, these two triangles are similar. ABD is similar to ECF. So this is proved. Pretty simple. By AA similarity. Okay. So this question states that sides AB, BC, and median AD of a triangle ABC are respectively proportional to sides PQ, QR, and the median PM of triangle PQR. So it's mentioned that AB divided by PQ is equal to BC divided by QR equal to AD divided by PM. This is given. Show that triangle ABC is similar to triangle PQR. Okay. So in this triangle, I can write AB by PQ is equal to, so BC, can I half it? So I just half BC divided by half. Now BC divided by half QR is equal to AD by PM. Now what is half BC? So we can say half BC is, because it's a median, AD is a median, so that means BD is equal to DC. So I can say half BC is equal to BD. So I can write AB by PQ is equal to BD divided by QM. So half, this is also equal to this, I'll just separately. So BD is equal to QM. So we can say AB by PQ is equal to BD by QM is equal to AD by PM. Because these three sides are similar, so in this triangle, so in triangle ABD and triangle PQM, when all the sides are similar, that means triangle ABD is similar to triangle PQM. When these two triangles are similar, we can say that angle B is equal to angle Q. Angle B is equal to angle Q. I'll mark it as 1. I'll mark it as 1 here. So these two angles are equal. AB by PQ is equal to BC by QR. Okay, this is given. This is given. And we also know that angle B is equal to angle Q. So from these two information, I can say that triangle ABC, complete triangle. So triangle ABC is similar to triangle PQR by side similarity rule. By SAS similarity rule. Because AB side is proportional to this side. BC side is proportional to QR side. And the angle between these two sides is same, exactly same. So by SAS similarity, these two triangles are similar. Okay, so coming to the next question. D is a point on the side BC of a triangle ABC. Okay, we'll just make A, B, C. Now D is a point. I'll just put it a point here. This is D. So that angle ADC, ADC, okay, this thought but ADC is equal to angle BAC. BAC. So they are saying this angle is equal to complete this angle. Okay. Show that CA square is equal to CB into CD. So first of all, because to remove confusion, I'm going to make these triangles separately. So when I make this triangle separately, I'll just make the bigger triangle first. So it will be A, B, C. And the other triangle where they have mentioned that the angles are a little same. This is A, D, C. Okay, so this is C, this is D, and this is A. Okay, now this angle is 1 and this angle is also 1. It is given angle ADC, angle ADC is equal to angle BAC. This angle is same. And we know that angle C is common. So angle C is equal to angle C. So if I say this angle is 2, this angle is also 2. So we can say that these two triangles are similar. I'll just mention this angle is 3. This angle is also 3. Now, if these two triangles are similar, so okay, but they are similar by which rule? They're similar by AA or AAA. Okay, I'll just mention similar triangle ABC is similar to triangle 1. What is 1? D A C. Okay, similar by AA similarity. AA similarity. So these two triangles are similar. Now, when these two triangles are similar, we can say that AB by DA is equal to BC by AC is equal to CA by CD. AB by DA is equal to BC by AC is equal to CA by CD. Okay. Now we need CA square. So CA square, CA here and CA square here. So I'm going to take these two. We'll cross multiply. So when we cross multiply, it becomes CA square is equal to BC into CD. BC into CD. And we have to prove the same thing. It is written CB into CD. We have to say BC into CD. Okay, so this is same. So this is proved. Okay, guys. So let's move to another question. Side AB, AC, and the median AD. Was it not the same question? Oh, so little different. So let's just make this triangle. Let's make this triangle. Yeah. This is A, B, C, and the median is this D. This is D. They're saying side AB, AC, and median AD. Side AB, so this side, and this side are similar to. We'll take another triangle. What is this triangle? It's PQR. It's PQR. So we say the median is M. This is M. Okay. So what is given? Given to us is AB by PQ is equal to AD by PM is equal to AC by PR. This is given to us. Now what we have to prove? That ABC is similar to PQR. Okay, in this question, in this specific question, what we have to do, because we don't know whether the third side is similar or not. So to prove it as with SSS similarity, so we have to make some constructions to check this happen. So what will happen is, as per construction, what we are going to do, we are going to increase, okay, AD, we'll extend AD to a length point. I'll say AM is done. This is point. PQ is also done. So I'll just say R. Okay. Okay. So that AD is equal to DR. And we'll join it with this point. Okay. So we have construction AD is equal to DR. We have constructed. And then we joined both the points. And we already know that BD is equal to DC. Why BD is equal to DC? Because it's a median. So we can say this side is equal to this side, and this complete side is equal to this complete side. Now, it happens in which figure? It happens only in a parallelogram. In the similar manner, we'll extend PM to a point called S and join it with S. So here also, this side is equal to this side, and this side is equal to this side, because PM was the median. And as per construction, we have increased it to this level. Now, we are looking at the triangle, this triangle, ABR. We are looking at triangle AB. Give me 1 second. Now, we have proved that this is a parallelogram. Now, what happens in a parallelogram? In a parallelogram, we know certain angles like this. We have to prove that triangle ABC is similar. So, okay. Okay, in a parallelogram, now ABCD is a parallelogram, ABRC is a parallelogram, and PQSR is a parallelogram, where AC, because it's a parallelogram, we can say, I'll just mention certain things like PM is equal to MS and QM is equal to MR. Okay, these things are, we know by construction or by median. So this and this by median, and this by construction. This by construction, by median, and by construction. Oh, my writing is bad. Construction. Now, we know that AC is equal to BR by opposite sides of parallelogram. Similarly, PR is equal to QS, opposite sides of the parallelogram. Now, if we look at the triangle ABR, triangle ABR, and triangle PQS. We are checking the triangle ABR and triangle PQS. We know that AB by PQ was equal to A, this was equal to this. So is equal to AC by PR, and that was equal to AD by PM, right? Now AC, can I replace AC with BR and PR with QS? So this implies that AB by PQ is equal to BR by QS. This is from these two equations. I put the value here, that AC is equal to BR and PR is equal to QS, because these are the opposite sides of the parallelogram. And also I can say that 2 times AD, 2 times AD divided by 2 times PS. Sorry, 2 times PM. 2 times PM. Now what is 2 times? So this implies that AB by PQ is equal to BR by QS equal to AR by PS. Now all the sides of triangle ABR and PQS are proportional, and these are proportional, so we can say that these two triangles are similar. So when we have proved these two triangles are similar, that means the angles in the triangles are also same. When the triangles are similar, the angles are same. So we can say that this complete angle angle B is equal to angle Q. So when angle B is equal to angle Q in a parallelogram, when angle B is equal to angle Q and angle B is equal to angle C, so okay, what is angle A then? Angle A is equal to complete angle A. Complete angle A will be, I'll just say angle A, complete angle, I'll just say angle A is equal to 180 minus angle B, because the sum of adjacent angles of a parallelogram is 180. Sum of adjacent angles of a parallelogram is 180. So angle A is equal to 180 minus angle B. So this angle, so we know that angle B is equal to angle Q. We know that angle B is equal to angle Q from here, because these two triangles have come similar. ABR and PQS are similar. So angle B is equal to angle Q. If angle B is equal to angle Q, we can say that angle A will be equal to angle P. We can say angle A is equal to angle P. So now this is first one equation, angle A is equal to angle P. And we also know that AB by PQ is equal to AC by PR. This is second. By 1 and 2. By 1 and 2, we can say that triangle ABC is similar to triangle PQR. And the reason is side angle side similarity rule. Okay. Okay, so move to the next one now. What does it say? Oh, a vertical pole of length 6 meter. A vertical pole of length 6 meter. Let's make it. Next question. So vertical pole of length 6 meter. Just make it a vertical pole of, what is this vertical length? Vertical pole of length 6 meter. Cast a shadow of 4 meter. इसका shadow बन रहा है 4 meter का. This is the shadow 4 meter. 6 meter, 4 meter. On the ground, and this at the same time the tower casts a shadow of 28 meters. So there is a big tower. This is a big tower which is casting a shadow of 28 meter. So this is X. See, these two triangles are similar. Why they are similar? Because this angle is 90 degree and this angle of the sun is also same. So they are similar by AA similarity. Now, when these two triangles are similar, we can say the sides are proportionate. So we can say that 6 by X is equal to 4 by 28. So from here, we can say X is equal to 28 into 6 divided by 4. So 4 7s are 28, 7 6 are 42. So it is, the tower is 42 meter high. It was a simple question, but it can come for 1 or 2 marks in the exam. So be ready for it. Coming to the next question. If AD and PM are medians of triangle ABC and PQR. If AD, I'll just make 2 triangles, ABC. So many questions related to median. ABC. And this point is AD. This is a median. That means this is equal to this. And PQR. Okay, this is PQR. PQR. And this is a median. PM. PM. This is equal to this. Okay. Where triangle ABC is similar to PQR. ABC is similar to PQR. So what is given to us? When these two triangles are similar, that means the sides are proportionate and the angles are equal. So what is given? AB by PQ is equal to BC by QR is equal to AC by PR. And angle B is equal to angle Q. You have to prove AB by PQ, AB by PQ is equal to AD. Okay, we can do that. So because these two triangles are similar, these sides are proportionate and angle B will be equal to angle Q, right? So angle, we can say this is angle 1 and this is also angle 1. These are equal because all the angles are, the 3 angles in a similar triangle are equal to the other 3 angles of the similar triangle. Now, now we have AB by PQ. We have AB, we are writing this part, okay? AB by PQ is equal to DC. So, sorry, this is BC. So instead of BC, I'm writing half BC. Half BC by half QR. Okay. So it will say AB by PQ is equal to what is half BC? I can write it as BD by QM. So AB by PQ is equal to BD by QM. When AB by BD is equal to BD by QM, this is 1 and this is the second one with 1 and 2. We can say it implies that triangle ABD, triangle ABD is similar to triangle PQM by SAS similarity. Why SAS? Why SAS similarity? Because this side is proportionate to this side is proportionate to this side, and the angle between these two sides is same. So these are proportionate. So when these two triangles have become similar, we can directly say that AB by PQ is equal to AD by PM. Hence, proved. Okay, so this brings to the end of the chapter. Please go through the chapter from beginning to end and subscribe to the channel in case you want to get more videos before the exams, maybe the practice questions. So you'll have a very short videos. So please subscribe to the channel and keep watching, keep learning. Thank you. Bye-bye. Take care.